This lesson is going to be a refresher on metric conversions and some new concepts I'm going to bring into the picture. This particular lesson, please make sure that you write down this as your notes for today and any guided practice that we do as well. You might remember from Chemistry 1 that we learned the metric conversion um, mnemonic device, and that mnemonic device was many kids have dropped over dead converting metrics many nights. So that is something that is new, that is not new, but we're going to add to that some new prefixes. But we did learn that many kids have dropped over dead converting metrics many nights. All of this that I'm underlining in green. We learned all of that in Chem 1, where if you take that mnemonic device, it gives you the first letter of each prefix in the metric conversion chart. Well, we're going to expand on that. There are prefixes larger than mega that we need to know for AP Chemistry, and there's some prefixes smaller than nano that we need to know. So to help you remember all of these, we're going to add to our sentence. So we're going to add the fact that exhausted parents tell guidance. Many kids have dropped over dead converting metrics many nights. Practicing for A's, right? Because if you're practicing for A's, you're going to be putting in lots of hours of studying. And maybe your parents might say, hey, don't you think it's time to go to bed? I am so tired of telling you to go to bed. So I just sort of added to our original sentence, and I added to it the fact that exhausted parents tell guidance that many kids have dropped over dead converting metrics many nights while up practicing for A's. So let's look at that and how it ties into the prefixes. So the prefixes, and this is going to be your metric prefix line we're going to write down here, start with E, capital E, exhausted, capital P, parents, capital T, tell, capital G, guidance, then mega is many. Then we have lowercase letters from here on out. Everything so far has been capital. So that was exhausted parents tell guidance. Many kids have dropped. Remember, deca is 2 letters, deca, D-A. Over is your home base where there's no prefixes, so we use null set or the theta. Dead is this lowercase d. Converting, metrics, and then we have our micro, okay? That's our Greek letter M. Metrics, many nights. And then the new ones are practicing for A's. So we have pico, and pico is kind of a little curvious Greek P. Practicing for is femta, and then A's is auto. Okay? So exhausted parents tell guidance. Many kids have dropped over dead converting metrics many nights. So some things we want to remember with this is that there are still our jumps of threes. Now this is a longer line, but if you look at where the threes are, it's much more balanced. You're going to find there are 3 decimal moves between E and P, between the peta and the tera, between the tera and the giga, and between the giga and the mega, and between mega and kilo. So notice 1, 2, 3, 4, 5. There's 5 places where there's jumps 3 decimal places between those prefixes. So 5 here, and there's also 5 at the end. So between milli and micro, there's a jump of 3, micro and nano, nano and pico, pico and femto, and femto and auto. All right, so those are where your jumps of 3 will be located. Everywhere else you move your decimal will be 1 decimal move. Now let's talk about what these are called. Each of these prefixes have a name. So I'm going to write the actual name of the prefixes underneath each letter. So we have the capital E, that stands for exa, E-X-A. And again, these are prefixes. And then the P is PETA, P-E-T-A. And then the T is Terra, T-E-R-A. And then the G, I'm sure you've all heard of this. Hopefully you've heard of terabytes as well, like with computer lingo. You have giga for gigabytes. And then we have the capital M is mega. And then, of course, we have kilo, hecto, deca. Here is our home base. So I'm just going to call that home base. It's our base unit. And then we go to deci, centi, milli, micro, nano, pico, femto, and then finally the A is ATTO, atto. So exa, peta, tera, giga, mega, kilo, hecta, deca, base unit, deci, centi, milli, micro, nano, pico, femto, and atto. So those are the names of those prefixes. And then one more before we do some examples, one more thing you need to know is what is the value for each of these prefixes? These metric prefixes represent a quantity, a value to a power of 10. So I'm going to write it in sort of a shorthanded format, but keep in mind these are 1 times 10 to this exponent here. But I'm going to start at the base units just to kind of give us a starting point. And the base unit, remember, is the ones place. And that is the same as 10 raised to the 0 power. If you take any number and raise it to the 0 power, then you get 1. So this is your ones place, or 1 times 10 to the 0 power. Now these are our small value prefixes on this side. So as you move over, you're moving 1 decimal place each time you go letter to letter. So from home base to deci, that's going to be 10 to the negative 1. Centi is 10 to the negative 2. Milli is 10 to the negative 3. Now between milli and micro is a jump of 3, so that's going to be a power of 3 also, so 10 to the negative 6. Then we have nano is 10 to the negative 9, because that's a jump of 3 here as well. We have jumps of 3s from here on out, so that means pico is 10 to the negative 12. Femta is 10 to the negative 15, and then atto is 10 to the negative 18. Now again, that's 1 times 10 to the negative 1, 1 times 10 to the negative 2, 1 times 10 to the negative 3, 1 times 10 to the negative 6. So these are very, very, very small prefix values. Our larger value prefixes are over on the left-hand side. So as we're coming this direction, we're getting larger by powers of 10. So this would be deca. Think about a decade is 10 years, right? Well, 10 in scientific notation is 1 times 10 to the first power. Hecta is 10 to the second power, which is 100. Kilo is 1,000, 10 to the third power. Then we have mega, 10 to the 6. Giga, 10 to the 9, because it's a jump of 3. Here on out, it's a jump of 3 each other place. So for tera, we have 10 to the positive 12. Peta is 10 to the positive 15. And exa is 10 to the positive 18. Now, I want you to notice this is very balanced. It's very symmetrical, if you will. So as you move this direction, you just have your negative exponents. As you move this direction, your positive exponents. Now, the new extension that we're going to be learning about is how to do metric conversions with dimensional analysis. In that process, it is very important that you understand which prefix corresponds to which value. You need to know the values for each of these prefixes. All right, so let's do some examples with metric conversions. So please make sure that you write these down as we go. And as always, you always want to show your work when you're doing any calculations. So I'm going to do just a basic example here for example number 1. So we're going to say we want to convert 26,490 kilometers. And we want to convert that, let's say we'll just go to megameters. Okay. So you have kilometers to megameters. This is a distance because meters is our base unit, but on the chart we're going from kilo to mega. So to show your work, because we're going to be going from between kilo and mega, and they are side by side here. So you want to write down many, jump of 3, kids. So that's the part of the chart that we're going to need. Now we're starting on kilo, and we're going to move our decimal to mega. So between kilo and mega, you go back 3 places. Remember, move letter to letter and count as you move from kilo to mega. That's 3. So you're going to come and you're going to move your decimal backwards to the left 3 places. So if you move it backwards 3 from here, 1, 2, 3, you will end up with your answer as 26.49, and the unit will be megameters. So that is a normal just decimal move, converting that from kilometers to megameters. Now, let's take a look at how you would do that same calculation, but using the process of dimensional analysis. So let's try it with dimensional analysis, because there are several occasions where you will need to use dimensional analysis to do metric conversions for some of our more advanced type problems. So same thing, but we're going to now use dimensional analysis instead of using the metric line, and this is where the values come in, where you need to know the values. So dimensional analysis involves starting with your given. So in this case, our given is 26,490, and it's kilometers. So when we use the process of dimensional analysis, you put your t-chart. And for this particular example, there's nothing in the denominator here. We just have our given, and it's an understood 1, so I'm going to shade that in. Now we're trying to convert this to megameters. So as usual, I'm going to put the unit I'm looking for over here. I'm going to megameters. Now, we're going to convert from kilometers to megameters. So we want to get our units in place. So I need kilometers to cancel. So I'm going to put kilometers on bottom, and I'm going to put megameters on top. Now, this is where dimensional analysis gets a little different than the normal kind of way you think about a conversion factor. Now, we're not doing any or breaking any rules, doing anything extremely different, but when you're trying to do a metric conversion that involves using the values from the metric chart to make your own equality, here is what you do. So whatever the prefix value is, so here we have mega. Mega's value is 10 to the 6th power. That means when I set up my conversion factor to make my equality a true statement, I need to make sure whatever mega's value is what I put down bottom beside of kilo. So I'm going to put 1 times 10 to the 6th beside of kilo, because mega is 1 times 10 to the 6th. So give the value for mega when you're setting up, making your conversion factor, put it down here. And then kilo is equal to 1,000. So that's the same as 1 times 10 to the third. So 1 times 10 to the third power goes here. So when you're trying to do dimensional analysis involving metric conversions, once you get your units in place, whatever the value is of the numerator here, mega in this case, the numerical value for mega will go down bottom, and then the value for kilo will go up top. It's kind of like you swap them. Now, we have now made a equality between these two because it is a true statement that 1,000 megameters is equivalent to 1 million kilometers. This has made the equality a true statement. All right, so now the way that I set this up, kilometers will divide out. So I'm going to plug this into my calculator. Always make sure that you're careful in doing these. Now, these are some of these you might end up being able to do it in your head if you're really mathy, but for those of you that are not, I'm going to go ahead and multiply it out. Remember, you multiply your first two together, your numerator. So we have 26.490, and we're going to multiply that. I'm sorry, let me go back. I said point. I should have a comma there. 26,490, okay? And we are going to then multiply it by 1 times 10 to the third, or 1,000, so times 1,000. And I'm going to then divide that by 1 times 10 to the sixth power. So you'll notice we get 26.49, which is what we got the first way we did it. Okay, so both ways work. The metric line using the metric conversion chart is the faster way to do this one, but sometimes it's going to be necessary that you have to use dimensional analysis. So that's why I'm showing you this process. And you'll see why in just a second when I do a little more advanced type problem. All right, so I'll go ahead and number that example 2. Let's look at another example. Example 3. Again, please put all these examples in your notes as we go through the guided practice here. So for example 3, we want to convert 6.82 centimeters squared, and we're going to use dimensional analysis. And the reason we have to use dimensional analysis here is because it is not to the first power, the unit is squared. So we're going to need to do some dimensional analysis to get all of our units to cancel properly. So I'm trying to convert from centimeters squared to decimeters squared. Now pay very close attention to the units. If something is squared, that means in order for it to cancel, I have to have it on bottom twice. So this is going to be a two-step conversion. So I need centimeters to cancel twice. So I'm going to put centimeters here and centimeters here. That will allow centimeters to cancel out both times. And I need decimeters squared on top. So to get decimeters squared on top, I need it decimeter, decimeter. Now I have written it out expanded. You could condense this and put parentheses, like put it one time and put parentheses around it and then square it. That would work. But I just want you to see the expanded view so nobody is confused, hopefully. And I'm really not sure why I put a cube there. Let me get my white out here. I think I was just writing out of habit. Okay, let me fix that. All right, so we have decimeters over centimeters, decimeter over centimeters. Notice we have our metric prefixes here, so we're going to have to swap the values like we did up here to get the equality to be a true equality. So since decimeters is on top, I need to think about what is deci equal to. Well, deci is equal to 1 times 10 to the negative 1. And we're also going to see centi. Centi is 1 times 10 to the negative 2. So let's keep that in mind. Since deci is 1 times 10 to the negative 1, we're going to put 1 times 10 to the negative 1 on bottom. I'm just going to write 10 to the negative 1 to make it short, but I know that's the same as 1 times 10 to the negative 1. And then centi is 1 times 10 to the negative 2. And I need to do the same thing again. Deci, so I'm going to put 1 times 10 to the negative 1 on top. Centi, 1 times 10 to the negative 2 goes up there. Okay? So what does that mean? So when you're plugging that into your calculator, you're basically going to plug in 6.82, and you're going to multiply that. 10 to the negative 2 times 10 to the negative 2 is 1 times 10 to the negative 4. And then you're dividing it by 1 times 10 to the negative 2. All right, so let's see what we get for our answer on that one. Plugging that in. We're going to plug in 6.82 times 1 EE to the negative 4. And I need to divide that by 1 EE to the negative 2. Oops, let me see. I got to figure out what I did wrong there. I must have. Okay, I see what I did. Got to add a parentheses there. Okay. All right, so there we go. So we see that if you plug that in correctly, you get 0.0682 for your answer. And we need 3 significant figures because that has our least sig figs. Remember, conversion factors have unlimited sig figs, so these numbers cannot determine our sig figs in our answer. Since this has 3 sig figs, we need 3 sig figs in our answer. So 0.0682. And the unit, because the centimeters squared canceled out completely, that leaves you with decimeters squared on top. So 0.0682 decimeters squared. I don't know why I want to keep writing cubed there. Okay, let's take a look at number 4, a fourth example. Now this is going to be a little more advanced also. Try to get a little more challenging as we go. So in this case, I want to convert 1 liter, and we're going to convert it to a English unit of measure, inches cubed. Okay, so this one is really more challenging. So we're starting with liters and we're trying to go to inches cubed. Okay. Now this is going to be a multi-step problem. We're going to think it through as we go. Now, a couple of other things you want to remember. This is something we learned in Chemistry 1 as a conversion factor. We need to think about our volume units, and we're dealing with some cubic volume units here, and we're also dealing with the liter volume unit, which is the unit we use for volume for liquids. So we want to think about some relationships we know between liters and the cubic volume unit. So you want to write this down, especially if maybe you forgot them. These are some true equalities you want to have memorized. One was that 1 milliliter is equal to 1 centimeter cubed. Another that we learned in Chem 1 is that 1 liter is equal to 1 decimeter cubed. And another one that we did not learn about in Chem 1, but is one that you want to memorize because we do use it a lot, is the relationship between centimeters and inches. And we know that there are 2.54 centimeters equal to 1 inch. Okay, so these equalities are going to help us along with the metric conversion units that I went over earlier. So let's think about this for just a second. We've got to get to inches cubed. And to get to inches cubed, that means towards the end of the problem, I'm going to be using the relationship between inches and centimeters. And I'm going to have it 3 times because I got to get it cubed. All right, so thinking about that. And so if I'm going to have inches cubed on top, that means on the bottom it will end up being centimeters cubed. Well, I know that a centimeter cubed equals a milliliter. So since I know that, if I can convert liters to milliliters, then I can convert milliliters to centimeters cubed, and then I could use the centimeters cubed, and then the 2.54 centimeters equals 1 inch. And those, then I could get to my final unit that I'm looking for here, okay? So let me show you what I mean. So my first move is going to be to go from liters to milliliters. So this involves what we just learned about up here. I need to get liters on the bottom to cancel, and I need milliliters on top. So since milli is equal to 1 times 10 to the negative 3, I'm going to put milli's value down bottom. Okay, 1 times 10 to the negative 3. Liters is at home base, and the value for home base is 1, so liters value goes up here. So we've just made an equality that says 1 milliliter equals 10 to the negative 3 liters, and that is a true statement. This is going to allow liters to divide out, y'all. Next, we're going to convert milliliters to centimeters cubed. And this is easy because they're equal to each other. But we're going to use dimensional analysis. I need milliliters to cancel. Centimeters cubed on top. So 1 centimeter cubed is equal to 1 milliliter. 1 centimeter cubed is equal to 1 milliliter. That's going to let milliliters cancel. Now I have centimeters cubed. So now we get to use this last conversion factor, and we need centimeters to cancel 3 times. So that means it has to go on the bottom 3 times. Centimeter, centimeter, centimeter. And I need inches on top each time. Inches, inches, inches. And that will give me inches cubed at the end. So let's plug in our numbers now that go along with these conversion factors. This conversion factor tells us that 2.54 centimeters equals 1 inch. So let's write that in. 1 inch equals 2.54 centimeters. 1 inch equals 2.54 centimeters, and 1 inch equals 2.54 centimeters. This will let centimeters cancel 1, 2, 3 times. That leaves you with inches on top 3 times, and an inch times an inch times an inch is an inch cubed. So we're ready to plug this into our calculator and get our final answer here. We're ready to plug this into our calculator and get our final answer. So let's do that. All right, so we have a 1, and then in the numerator, everything else is a 1, right? So there's nothing else to put in the numerator. So that means I'm going to plug in the denominator numbers next. So I'm going to say divided by, and I'm going to go ahead and open my parentheses key up. So I'm going to divide by 1 times 10 to the negative 3, 1 e to the negative 3, and then that's times 1, and then times 2.54 times 2.54 times 2.54. So times 2.54, 2.54, 2.54, close parentheses. All right. Press equals, and now we're going to round this to 3 sig figs because that's our fewest sig figs. Our given had 3. So you're going to write for your answer 61.0 inches cubed. Now hopefully you will be able to do the guided practice worksheets on your own.